I am Dr. T. Swahasini, lecturer in physics, Government Degree College, Nagari, Chittoor district. Today, explain the topic vector atom model. This topic is in 5th semester, 6th paper, modern physics. What is atomic spectrum? When atoms are excited, they emit light of certain wavelengths which correspond into different colors. The emitted light can be observed as a series of colored lines with dark spaces in between. This series of colored lines is known as line spectra or atomic spectra. Another name is another spectrum. According to the Bohr theory, the electron moving around the nucleus in circular orbit, it takes only 1 degree of freedom. There are some drawbacks in Bohr's theory. To overcome the Bohr's theory, the Sommerfeld developed the theory, the electron moving around the nucleus under an inverse square force like planet around the sun. It must describe elliptical orbits. In the elliptical orbit, the position of electron at any time may be fixed to two coordinates, small r and phi, where small r is the radius vector and phi is the angle which the radius vector makes with the major axis of the ellipse, or that is azimuthal angle. So, the Sommerfeld theory of elliptical orbit could not explain the fine structure of the spectral lines. So, both the Bohr and Sommerfeld's theory could not explain the how the fine structure of the hydrogen spectra and to calculate the energy of system and frequencies of radiation emitted. Both the models could not explain the how to distribution and how to arrangement of electrons in atoms. And also both the models do not throw any light on the intensities of the spectral lines. Next, both the models could not explain the anomalous Zeeman effect and Stark effect. What is Zeeman effect and what is Stark effect? If the atom is placed in magnetic field, then applied to the magnetic field to the atom, each spectral line splits into several lines is called as anomalous Zeeman effect. And the what is Stark effect? When the electric field is applied to the atom, each spectral line splits into several lines is called as Stark effect. Next, why we develop the vector atom model. So some drawbacks, both the Bohr and Sommerfeld's theory, Sommerfeld and Woolen and Goldsmith, some other scientists or developed the physicists developed the vector atom model. Vector atom model has two concepts. One is space quantization. Second one is spinning electron. What is space quantization? According to the Bohr's theory, the electron moves in circular orbit. The electron has only 1 degree of freedom. In case of Sommerfeld's elliptical orbits, the electron possesses 2 degrees of freedom. So, in additional, quantum condition is also required to describe the actual state of affairs. So, in a vector atom model, the orbits are assumed to be quantized in magnitude and directions both. So, according to the rule of space quantization, the electron orbit can only set itself in certain discrete positions with respect to the field direction and not in all positions, making all possible angles with the field direction, and it is suggested by the Sommerfeld. Next one, second, spinning electron. What is spinning electron? So, some physicists, Uhlenbeck and Goldsplit, two physicists, says that the electron revolves not only in an orbit around the nucleus but also about its own axis. The orbital and spin motions are quantized not only in magnitude but also in direction according to the concept of the vector in this space quantization. So, the electron has two types of motions, orbital motion and spin motion. The angular momentum of the atom will now be due to orbital motion and spin motion of the electron. According to the quantum theory, the spin motion like orbital motion should be quantized. The orbital and spin motions are quantized not only in magnitude but also in direction according to the concept of space quantization. The two are considered as quantized vectors and hence the atom model is called as vector atom model. So, the two fundamentals of postulates vector atom, one is space quantization and second one is spinning electron, have been experimentally verified by Stern and Gerlach experiment while studying the behavior of atoms in non-homogeneous magnetic field. Next one, quantum numbers associated with vector atom model. So, the 7 quantum numbers are associated with the vector atom model. First one is the principal or total quantum number, second one is orbital quantum number, third one is spin quantum number, fourth one is total angular quantum number, fifth one is magnetic orbital quantum number, sixth one is magnetic spin quantum number, seventh one is magnetic total angular quantum number. So, we explain one by one. First one, the principal or total quantum number. It denotes small n. It denotes as small n. The quantum number belongs to this principal orbit. It was electron belongs and it identical that used in Bohr-Sommerfeld theory. It represented by small n. The principal quantum number n can have only non-zero positive integral values. That is, small n is equal non-zero. So, it starts from 1, 2, 3 up to infinity. The energy levels are shells of electrons corresponding to n is equal to 1, 2, 3, 4 just like. So, they are denoted by letters, capital letters K, L, M and O respectively. So on. The number of electrons in a shell, it is limited to 2n square. Suppose n equal to 2, so the number of electrons in a shell, so n equal to 2, that means 2 square into 2, that is equal to 8 electrons in a shell. Next one, second one is orbital quantum number, it denotes small l. This quantum number shows that the shape of the orbital occupied by the electron and the orbital angular momentum of the electron. So, it occupied by the electron and the orbital quantum number of the electron starts from 0 to n minus 1. So, this value refers to subshells, it indicates subshells. So, the orbitals corresponding to small l is equal to 0, 1, 2, 3. So, it designed as SPDF etc. So, third one is spin quantum number. It denotes small s. So, this quantum number has been introduced to account for the spin of the electrons about their own axis. The magnitude is always half. So, since the electron can spin clockwise or anti-clockwise, so, there are two values given to small s. So, one is plus half, second one is minus half. It depends upon whether the electron spins in one direction or other direction. So, two electrons with same sign of the spin quantum number are said to have parallel spins, while those have opposite spins have spin quantum numbers are said to be opposite spins or paired up spins. Next one is total angular quantum number. It denotes small j. So what is small j? This quantum number represents the resultant angular momentum of the electron due to the both orbital and spin motions. So the its numerical value is vector sum of L and S. It is usually expressed as j is equal to L plus small l plus s. So j is equal to small l plus 1 by 2. The plus sign gives used as s is parallel to small s and j is equal to l minus 1 by 2. It gives used s is anti-parallel to l. Every l value except that for which l is 0. So what is L is 0? It's split into two levels with different energies. This explains the fine structure of the spectral lines, although the number of lines is limited to selecting rule delta J is equal to 0 or plus or minus 1. Next one, fifth one is magnetic orbital quantum number ML. So when the atom is placed in a strong magnetic field, the electrons with the same values of principal quantum number n and the orbital quantum number small l in different directions, and the magnetic moment is divided into orbital quantum number ml and the spin quantum number ms, and the total angular magnetic moment quantum number is mj. So the orbital magnetic quantum number is varies from plus L to minus L. Thus, for each value of L, there will be 2L plus 1 possible values of ML. So, when the vector L is inclined in an angle theta, the direction, so ML is equal to L cos theta. So ML has to be an integer and cos theta can never exceed unity. What is unity? Unity means 1, exceed 1. So for L is equal to 0, ML is equal to 0, and for each value of principal quantum number n, there is only one orientation is s orbital. For L is equal to 1, ML is equal to plus 1 minus, so that means 2L plus 1 gives 3 values, that is plus 1, 0, minus 1. So 3 permitted orientations are possible. For L is equal to 0, ML is equal to plus 2, plus 1, 0, minus 1, minus 2, that is 5 permitted orientations are possible. Next, for L is equal to 3, ML is equal to plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, that is 7 permitted orientations are shown in the this magnetic orbital quantum number ML, that is F orbital. Next one is sixth one, magnetic spin quantum number ms. So the value of ms varies from minus s to plus s excluding 0. Thus for each value of s, it can have only 2 values. So s is equal to plus half and minus s is equal to minus half. Next one, last, magnetic total angular quantum number mj. So it denotes mj. So the value of mj varies from plus j to minus j excluding 0. So and it possesses only half integral values. This how explains the this explains the splitting of spectral lines in a strong magnetic field. Thanking you.